do a bit of a review. I'm going to review a little bit what it is that you were supposed to have watched. So if you didn't watch the lesson, you will be a little lost, I'm afraid to say. Okay? So we're on 97. I'm asking you to calculate the following to 4 decimal places. Then we're going to, without a calculator, just predict. Right? Predict the value of the supplementary angle. So let's figure out what sine of 73 is. Grab your calculator, you go sine of 73. That is 0.9563. Now we're going to go cosine of 118. That's negative 0.4695. Tangent. I'm pretty sure I didn't cover the tangent portion on the video, but it doesn't hurt. It behaves the same way as cosine. And then sine of 176 is 0.0698. So we stated all of them using our calculator. Now we're going to predict. This is another way of, it means the supplement. Okay. That's what that means. So don't be scared of 180 minus theta. It's just, hey, like find a supplement and find its value. So in a sense, we know what sine of 73 is. Its trig ratio is this. So sine of what's 180 minus theta? This is theta right here. 73, right? So this is 107. Let's go to this one. Right? Cosine of 118. So the supplement would be cosine of 62. And we will predict that. Tangent, the supplement of 12 is 168 degrees. We'll predict that. And then sine of 174, its supplement is just 4 degrees. And we'll predict the trig value there. I didn't do this on the video, did I? Pretty sure I didn't. Okay. So what we know about sine, right? If you can identify, oh, okay, there's both sines and these are supplementary, right? I will just say they add up to 180. Okay. If you notice that, then we actually know that the trig ratio will be exactly the same. Right? No change. It doesn't matter if it's acute or obtuse, the trig ratio is the same. Sine does not differentiate between them. Okay, that's a problem. Now you have cosine of 118 is negative, right? Negative 0.4695. You check. Okay? You check. It's like, hey, these angles, we know they add up to 180, but that's something you would want to check if I had already filled this in and asked you, are they the same? They are 180. So the difference between here and here will be the actual value will be exactly the same. However, there's a positive here. I'm actually going to go ahead and do that. Okay, there's a positive there. So you can predict based on cosine. You can say, hey, if cosine 118 is negative 0.4695, then cosine of its supplement will be positive, and it happens to be an acute angle. Tangent of this is 0.2126. Tangent of its supplement is negative 0.2126. I know I didn't cover tangent, but it behaves the same as cosine. Okay. Next, sine of 176 is that. Sine of 4 is going to be exactly the same. Okay, no change. I'm going to put next to the sine questions here the fact that there was no change. We did not change anything in terms of that. Maybe I'll highlight that. And exactly the same. This one is exactly the same as that one. This one is exactly the same as that one. Okay. So this is a concept I want you to understand. And the main fact, maybe I'll use a different highlighter, just saying, hey, for cosine, they had different signs. Same as tangent. Tangent has negative here. And let's put a positive in front of this one here. So the values themselves, the trig ratio is the same, but the sign changes if it's the supplement, if they're supplement of each other. So that takes us a step further. It says here, state all possible values for the following. Okay. So what this wants you to do is figure out, okay, sine of theta is this. So theta will be sine inverse, write this down, right? Sine inverse of that. You're about to find the angle itself. So you grab your calculator and you're going to say, well, I'm trying to find the inverse. So second sine 0.4327. Okay, you're going to hit equals and you're going to get 25.64 degrees. However, that is not the only possible angle. It is possible that sine, like when you do the calculation, that you're actually trying to find the obtuse angle. Okay? I know this is Monday morning and you're like, what? Right? So imagine sine found, like by default, it will always give you the acute angle. So this is 25.64. But it could be that you were referring to this angle right here. How will you find that? You go 180 minus 25.64 to get this part right here. So you just go ahead. I'm just going to keep this on my calculator and go minus 180. So it's 154.36 is the other possible angle. This is 154.36. Because sine doesn't differentiate. It will always give you the acute angle. But it could be that you're referring to the obtuse. So you have to say, hey, there are two possible answers, technically. Okay. Let's keep going. Oops, sorry. So here's cosine. Cosine, there's no problems. We don't have to do the two answers, okay? So we go theta is cosine inverse of 0.675. Theta is, let's go ahead and do that, second cos 0.675. And you get an angle of 47.55 degrees. No ambiguity, no. Okay. One more, okay? 97. So here, watch this. You can predict things here. Cosine of whatever angle we're looking for has a negative. See that? Will be an obtuse angle. Okay. It will be an obtuse angle. There's no question about it. So we'll go, well, theta is cosine inverse of negative 0.589. Let's go ahead and find the angle. Second cos of negative 0.589. Make sure you type in the negative And there it is, 126.09 degrees. Okay. That's it, only one answer. No ambiguity. What about the next one? Sign here. You know it's going to be ambiguous. You cannot bank on this being, it will always give you an acute angle, but you know it could be acute or obtuse. So we go theta is sine inverse of 0.9738. Theta is sine inverse of 0.9738, 7686. But you must go comma, take 180 away from what's on your screen, and there it is, it's 103.14. There are two possible angles here. Okay. So when it says state all possible solutions, that's what we mean. Sine is the only one that you have to worry about. Okay, you do not have to worry about cosine or tangent. Okay. So before I move on, I will ask you to try this chart, fill that in. I will do one with you before I let the rest be your responsibility. So for example, sine of the angle we're interested in has this trig ratio. Will the angle be acute, obtuse, or possibly both? Because it's sine, you have to say that it could be either or. I will highlight sine. Because of sine, we're determining that it could be either or. How do you find the value of theta? Easy peasy. Just use your inverse. And then, right, so this will be the first value, and then you go comma, you just subtract that from 180, 138.33. Okay. So you've got two possible angles. I want you to do the rest, and also go to 98 at the top there. This is a review from the lesson, right, that you watched. So I want you to do this table, and then I want you to go to 98 and just do the top here, just that part right there as well. And then I'll go over it, and then we'll move on to the meat and potatoes of today's lesson, okay? I'm just going to do the chart quietly. This one is a weird one. we'll just leave it like that. It's not, it's correct, but you won't have to worry about tangent. There we go. That's a table filled in. Okay. So we've got, I knew this was acute. Why? Because it had a positive trig ratio. Okay, I just figured it out. This one, I knew was an obtuse angle because of that negative, right? So I figured it out. Sine, it could be both. So you just go ahead, automatically gives you the acute, you find the supplement. Tangent, we know it's going to be obtuse. This is actually 180 minus, like you subtract this from 180 to get the actual angle, but that's okay. Cosine, because it's cosine and it's positive, I know my answer is going to be acute, so there it is. So this should be, it's just as simple as that. Next, here, I'm going to ask you from time to time, like on the test, right? I'm going to ask you, hey, is this valid to say this? The first thing you want to check is, are these supplementary? And there are, right? It's 180. Check. Is cosine exactly equal to cosine? This is incorrect. One of them should have a positive or a negative in front of it. So this is not valid. False. Okay. Cosine of 7, if you had negative cosine of 173, that would have been okay. Is true, right? So, and this is how you can absolutely make sure. Watch this. You go cosine of 7 is 0.9925. If you go negative cosine of 173, like you actually type this in as is, you also get 0.9925. Right? So you know that they are the same. Over here, are these supplementary? You check, and they are. And one of them has a negative in front of it. That is true. Sine and sine, these do not add up to 180, so it's automatically false. Okay, their numbers that you get are going to be completely different because they're not even supplementary. Cosine, are these 180? Yes. One of them has a negative in front of it? True. Okay. Are these supplementary? Yes. One of them has a negative in front of it? That makes it true. Supplementary? Yes. One of them has a negative in front of it? True. Okay. So that's kind of how you, and if this is kind of gibberish to you, go back and watch the lesson. I do go over that as well. Okay. Maybe I'll just say, why is it false? Angles are not supplementary. Then it's immediately false. Then you don't even have to like go further. Okay. So that's that. I want to keep going though. So come with me. You know what? If you need to review this particular, I'm going to actually say homework for now 99, page 99. If you want to review this, what we just did again, I'm going to post a key to page 99. I will write this down again before I send you off. I will write that down. So I will skip a few pages here with you. And you were supposed to have, this is the meat and potatoes of the lesson. Okay, this is where it's at, right? And I hope you have this filled in. And something like this should be on your study sheet. Do I use my iPad? This is page 103. Do I use my iPad on it with a swinging rope? Okay. You would only know what I'm talking about if you watched it, right? So I will just briefly review that though. Okay, when given a non-right triangle oblique and we determine that it is SSA, okay, this is very important. So if you've copied this down, just follow along, make any extra notes that I may not have mentioned on the video. When it's SSA and it's gonna be sine law, we need to take extra precautions, right? And so SSA when the angle is acute. So I'm gonna focus, this whole page here is gonna be acute only. So you gotta make sure you understand that. Okay. You always want to force your diagram to look like this. We're gonna force the diagram to look like this. Okay. And then you have your fishing rod. This is one of the sides given, and this is the other side given. But we're not gonna close the triangle because when it's SSA, we have a problem. We need to make sure we can actually have a triangle. Okay, so rod string. So what we ask here is, this could be different than your video, but it's not going to be wrong if you just keep yours, right? You need to ask, is the string, right? Is the string greater than or equal to the rod? Those of you who wrote the notes, did I do equals to? Yeah, that's very important. Okay. Is the string, can I just say something? The string is like the star of the story. It's always like the main attraction, right? So we're always going to ask ourselves like, hey, what's up with that string? We're going to compare it to two things, okay? So string. Down the road, I just go SR, right? I don't necessarily go string rod, but for now, we got to just ask, is the string greater than or equal to the rod? And you're like, what do you mean? The number. You look at the numbers, right? You're going to fill in these numbers. There's going to be numbers here. So is that number bigger than or equal to whatever the rod is? So I like fishing, right? So rod string is the way I go. If the answer is yes, right? If you go this way and you answer yes, right? Then you have one possible solution or one possible triangle. That's the same thing. Okay. There's one possible triangle that can be created with that information. If you say no to this, you need to go down this path. You need to then find the height, right? So that's the arrow. You would go to find the height. And we already know that the height is going to be found by going rod times sine of the only angle that's provided to you, which is this one. Okay, that's x. Maybe we'll give it a color here. Okay, we're talking about the only angle that's provided here. That's how you find the height. You're gonna have to figure it out. And so I don't know if I did this in the notes, but I'm gonna say, okay, that height, this height that you calculate, right, gets introduced to this triangle now. Notice that I didn't care about the height until this point. Once you say no, it's like, is it no? Then you need to find the height, and that is the height right here. Okay, and it makes a 90 with the ground. This is the height. So this is new probably. I didn't do this in the video you watched. I always try new things here. Okay, so you need to find the height. Then you need to ask yourself 3 questions. Who's the main character? The string. You're going to say, is the string, what do I start with in your notes? Less than? Is the string less than the height? That's the first question you're going to ask. Next is the string possibly exactly equal to the height? That's the other one. And the last one is the string greater than the height? You're going to ask, so I'm going to highlight the main character again. string, string, string. You can only go down one path, guys. You can't. You're going to end up in one of these sections, not in the multiple, only in one. Okay. By the way, you may also end up in this part right here where you're done. You don't need to worry about the height. I should probably say in brackets, no need for height. That is probably something students miss quite often. They still want to calculate the height if they end up here. No need for that, right? Once you can say yes that the string is greater than or equal to the rod, remember, or equal to, then you're over here, you're done. No need to find the height. So write that down if you haven't done that. I'm going to use maybe just green brackets here and underline it because my green kind of just makes it worse. It just crosses things out. All right, so here it is. If the string is less than the height, there's no triangle. How did I do that in your notes? I can't remember. But I probably will have done something like this, where this is your rod, and this is the string, and the string is just dangling like this, right? So it's making a path like that. This is your height. Right? This is the height, but the string is too short. Like the string itself is shorter than the height. So no triangle, no solution, no triangle. You can't close that. And then if the string is exactly equal to the height, you have exactly one triangle. Okay, this is the rod. This is the string, which is equal to the height. String. So you have one solution, one triangle. But what kind of triangle in particular? One right triangle. So what's the difference between this and this one up here? Sorry, you can't see that. I'm going to try my best. This one is not a right triangle. Okay. This one is. So still there's one solution here, but here in particular you have a right triangle. Lots of fun, eh? I know. And then the last most interesting of all, if you determine that the string is greater than the height, you have two solutions. You have, let me do this here. I'm going to try my best. You have one instance where the string swings in. This is your rod. This is your string. Here's the height, guys. Okay, the height is right here with the ground, but the string swings because it swings this way, and then it will also swing out like this. So you have your other triangle out here. Okay, so it does that. So string, string, and string. So you have one here, one there. So I will now split it up into the two triangles because sometimes students take the wrong one. They think this is a triangle here. This is not the one we're talking about. We're talking about this one, or this one where the string swings out. So two solutions, two triangles. And here I will probably add at the bottom. Did I add some of the justifications down here with the letters? Okay, so you got to remember, if you go from the top of this chart, from the top, you made this claim right from the beginning. And then you're making one of these other claims. So if you end up in this section here, you have said that the string is shorter than the rod and that the string is shorter than the height. That's what you've made here. This is the justification for you saying this, that there is no solution. If you end up here, guess what? You've also said that the string is shorter than the rod to get here. But in this case, the string is exactly equal to the height. So that's the justification here. And then the last one to end up in this one, and I will use this space here perhaps, is that, yeah, you've made this claim again that the string is shorter than the rod, but here the string is greater than the height. So watch this. It's always string is shorter than the rod to get here, but it is the second part. What happens when you compare the string and the height? That is a different story. So you know what? I will add something, and I'm pretty sure your notes don't have this. When you say no, right? When you say no to this statement, you know what you are saying? Is that the string is shorter than the rod, right? That's what's happening when you say no. You're actually saying string is shorter than the rod. That's probably, I don't think I added that in your notes, so maybe add that. And so with this in mind, we're going to now explore the rest. Okay. Yeah, I know. You're scratching your head maybe a little bit, and this isn't very common. I made sure this wasn't an issue up until this point. And you know what? It's going to be very obvious when this is what I'm asking you. It's going to be like, how many solutions are there? And you're like, oh, okay, it's the flow chart, right? So here we go. One more, 104. SSA, when the given angle is obtuse. I know some of you faithfully wrote this all down, but even for myself, just to get us started today, I need to once just cover this. When it's obtuse, I want it to look like this, right? This is obtuse. The angle is greater than 90. Okay, like sometimes I have students draw me an acute triangle and it's 120 degrees, that angle, right? So it's got to look like this, bigger than 90. So there's a rod. This one is way easier. If the rod, oh, it's always about the string, right? So we're gonna focus. If string is greater than the rod, you have one solution. I may have done this differently in yours, but it's still the same. If the string is less than or equal to the rod, no solution. That's it. No need to find the height. Nothing like that. I have that nice and big up here. Watch. No need to find the height. Okay. So let's explore this a bit. Let's play with what we've just learned here. So we're going to go to 106 for now. Did I do 106 in the notes? Yes? 106 is done? Okay, thank you. So in that case, I will not do 106 right now because it's already done. We'll go to 107. That one I'm quite certain I didn't do yet. I think that you're gonna have to become creative at making a flowchart that doesn't take up like a whole page, right, on your study sheet, because you're gonna need it. Okay, so let's say we're on 107 here. Triangle XYZ, right? Z is 41 yards, Y is 36, Y is 62. Remember, this is only a problem. Whatever we've learned right now, it's only if it's an SSA. Okay? How do we know this is an SSA? Because you've got a pair and a side. Okay? That means this is an SSA, so you got to watch out. Okay? Watch. Especially when there's no diagram, you got to watch out for that. Okay, so here we go. Draw your diagram. like this, you're going to force that angle, whichever angle is given to you, you're going to put that over here, 62 degrees. You're going to put the side 36 yards up here. Because remember, this is a pair. You start with your angle, put it over here. The side that's across from it, you put it over there. The only other side that they're giving you is Z. So we're going to put that over here, 41 yards. Okay, so you set it up like that. Can we also make sure this is acute angle? Okay. So what you want to do here is ask yourself, string and rod, what's happening here? Well, the string is shorter than my rod. You need to find the height. So let's find the height. Height is 41 yards, so the slanted side is what we covered before, times sine of 62. Let's figure out what that is to 2 decimals. 41 times sine of 62, that's 36.20. Ooh, that's close. So this is the first conclusion I made. And because anytime the string is shorter than the rod, you have to find the height. Okay, now you're going to ask yourself, string and height, what are you going to say here? Look at the numbers. I know that my string is shorter than the height. So what's happening here? It's the fact that the string is up here dangling like this. And it can't quite close that. Okay? So therefore, no triangle. No solution. I don't care which one you use, but you need to be comfortable with both of them. So what I forgot is to say that this is my rod and this is my string. That's important. If you want to use string and rod, you got to label your diagram accordingly. Okay? You got to do that accordingly. Okay. Let's do some whiteboard work with this, with the rest of these. So you're gonna grab your booklet. You're gonna, I'm gonna pair you up, or do you want to pair yourselves up? 2, 4, 6, 8, 10. We're perfect. Or groups of 2. And just try this out a little bit. Page 111. So we're gonna actually solve triangles, solving SSA with 2 solutions. So here we go. I will ask you, and I will say how many solutions are possible. But it ultimately, our ultimate quest is going to be solved for side E. Right, guys? I'm going to say this. Sine law, cosine law still works the same way. It's just the fact that we now have more to solve. So when I ask you how many solutions are possible, you look, okay, side, another side, and an angle. Hey, that angle is across one of the sides. This is SSA for sure. 2 sides, 1 angle, but they're across from each other. So you got to check. You do the string rod thing. The only angle that is given to you is 27. Okay. The side that should be across this angle is 25 miles. The other one is 30 miles. So I'm going to do the check right here. I'm going to put an R and an S there. So string is shorter than rod. That means I have to find the height, which is 30 times sine of 27. 30 times sine of 27 is 13.62. So we know how to calculate that. That's why I'm not spending time on that. Okay. Now you're saying, hey, what about the string and the height? Like, what should I say? Numbers, right? Go by numbers. The string is greater than my height. Therefore, I can say 2 solutions. Possible. Okay. So given this situation, I can't I can't say what the triangle looks like. I don't know if it's going to be one of those that has an obtuse angle in it. I don't know if it's one of those that has an acute angle in it. So therefore, I must do both. Okay. So I'm going to cut that. So this would be worth probably 2 marks, just you identifying how many solutions there are. So I'm going to split this in half here. Okay, I'm going to split my page in half. So solution 1, I start with this one. Where the string hits the bottom on the far side as it's swinging way out. So what goes here? It goes D, and you got to be careful. What will go over here? Because remember, I put this 30 miles. I want to keep it as close as possible to what I started with. Now, what 30 miles was side what? Side F, correct? So that means that angle F will be here. And therefore, angle E, because it's triangle DEF, will be up there. So it's asking for this side, right? That's what we're wondering about. What more do we know about this triangle? We know that this is 27 degrees. And here you go. Okay. I will tell you this. This is going to be, I'm going to call this F1, E1, and therefore E lowercase 1 as well. So this is going to be the first triangle we're solving. Later I'm going to call all of these 2, 2, 2, okay, for the second possible solution. So here we go. There's a pair. So we go sine of 27 degrees over 25 miles over. What is the only thing that we can solve for right now? Angle F, right? That's the only thing we can do because the 30 is over there. So we're going to go sine of F1 over 30 miles. We cross multiply and divide, right? We know that sine of F sub 1 is 30 times sine of 27 over 25 miles. You're probably wondering what happened here, right? This is sine of 27. Believe me, it's sine of 27. There we go. That, if you multiply that out and divide, you get 0.5447 dot dot dot. So angle F1 is sine inverse of 0.544 and so on. Angle F1 turns out to be 33.01 degrees. I don't think this is anything new to you, right? I'm going to underline that because that's important. Keep going. Now that I have angle F1, I can find the angle up top here, which I call E1. So angle E1 is 180 minus 27, the one I already know, which is angle D, minus 33.01. Angle E1 is 119.99. Also important to me, but not the ultimate. Can I use sine law to solve for everything else? Yes. I'm going to use cosine law because there's a trick that I'm going to show you for the second one. Watch this. E1, follow me on the diagram, is up here. I know side, angle, side. Like I have this top here. So I'm going to use cosine law to solve for this side. Okay. I choose cosine law to solve E1. Okay, I'm going to make that statement because some students choose to go sine law. There's nothing wrong with it. I'm not going to take marks off. So E1 squared is equal to 30 squared plus 25 squared minus 2 times 30 times 25 times cosine of E1. I just found that 119.99. So E1 is the root of all of this. And if I compute that, this is what I get. So you get 47.69 miles. Boo. Normally this would have been it. But unfortunately, sine law doesn't know the difference, right? So we also have to now consider the other triangle that's possible. I know I'm gunning it a bit, I know that, but just follow along as best as you can. I'm saving the clicking right now. You just write it down step by step. But there it is. That's E1, first option. Second solution, I'm going to try to keep that all on there. So here's the other one. This one is where it swings in. That string here, I'm going to actually highlight that. This is the string here, which was the string up there. And now it swings in like that. This is still D. This is still F, because F is here. And this is E. Okay. What's still remaining the same? Well, the fact that this is 27 degrees hasn't changed. The fact that this is 30 miles hasn't changed. That this is 25 miles has not changed. But now I'm going to give it different sub notation. So F2, E2, and therefore E2 is what I'm interested in this particular triangle. I forgot to say solution 2 up here. So here we go one more time. Watch this. Sine of 27 over 25, because that's a pair. Sine of F2, that's the only thing we can solve for, over 30 miles. So let's, wait a minute, look at this. Look at this setup, and then look at that setup. 27, 25, F30. 27, 25, F30. Aren't we going to get the same answer? Don't you think we're going to get the same answer? But isn't this clearly an obtuse angle here? That's the problem here. So I'll say sine of F2 is 30 times sine of 27 divided by 25 miles. That is 0.544, just like before. Angle F2 is 33.01, but it is obtuse. So I can't have that. I know that F2 is going to be the supplement of that. And this is the problem with sine law. It doesn't know the difference. So we need to come in there. So that is 146.99. Therefore, now I can find angle E2 up there. This is 180 minus 27. This is sum of triangle. Okay, don't mix that up. Minus 146.99. E2 is 6.01 degrees. Also important to me, so I'm going to underline that. I'm going to underline the 146.99. So cosine law. So to find E2 squared, we still do the same thing. 30 squared. Let's do this before the bell goes. Cosine of 6.01 degrees. E sub 2 is the root of all of that. Notice that the angle is different back here. That is 33.24. E2 is 5.77 miles. Okay, your homework. If you want to review what we did at the beginning of this class today, is page 99. And if you want to try this particular case, you go page 112. I would strongly encourage you to practice it right next door, okay? Right next door. The key is there. The answer is right next to it, but I will also post the key where I work it out, okay? Thank you, guys. I know it was a long day.